So this is a review up on 7.2, which is on addition and subtraction formula of trig functions. So if we have sine of negative 5 pi over 12, the first thing we want to do, right? We can solve from here if you want to deal with radian measures. I don't. So I would like to change that into degrees. Okay. The quickest way to change 5 pi over 12 into degrees is we know that pi equals 180. So just multiply this instead of pi by 180. Okay. So if we do, I know that 12 goes into 180 15 times. So that's negative 75. Negative 5 times 15 is negative 75. So we essentially change the problem up to sine of negative 75. Okay. Now, I want to talk to you guys about this. When dealing with addition and subtraction of sine, cosine, and tangent, we're going to always have this funky degree measure or this funky radian measure, right? And we're trying to get two numbers adding or subtracting that we know of, right, to get 75 degrees, right? In this case, negative 75. What we know in our first quadrant is 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees, right? That's all we know in the first quadrant, and then every multiple of that in the different quadrants, right? Quadrant 2, quadrant 3, quadrant 4 would just expand on these values. If I take 45 away with my finger, if I subtract or add them, right? 90 minus 60 is 30. 60 minus 30 is 30. 90 minus 30 is 60. And then 30 minus 0, and anything minus 0 is just that number, right? That will come out to be stuff that we know, right? So it doesn't really help us when you get that funky measure like negative 75 degrees, right? So right off the bat, I know I have to do something with this 45. Okay? That makes sense? Okay? So knowing that, I just did this. Sine of 45 minus, because I know I have to go to a negative 75, right? So I'm going to subtract 45. 45 minus what equals negative 75? 120. Yeah? So that's the thing that I'm going to work with. Sine of 45 minus 120. And these are degrees. Okay, so sine can't change signs. So I know it's sine, cosine, cosine, sine. Since that's a minus, this is a minus, and this is going to be 45, 120, 45, 120. And by now, we should have memorized what the sine of 45 and the cosine of 45 is. If you did not, then go ahead and do that triangle, right? Of 120, we can kind of see that 120 has a 60-degree angle in our second quadrant. So this is square root of 3. This is 1. This is 2. That should be 2. This is negative because of my negative x-axis, positive y-axis. So the cosine of 120 is negative 1/2 times negative 1/2. And the sine of 120 is square root of 3 over 2. Okay? So doing this math, just multiplying it across, right? Negative square root of 2 over 4 minus square root of 6 over 4. Since we have the same denominator, I'm just going to put it all under 1. Negative square root of 2 minus square root of 6. Okay? Questions on that? Yeah. Cosine of 120 is going to be this triangle here, right? Because this is 120. Yeah. So it's this reference triangle where cosine is going to be x over r, or adjacent over hypotenuse. Okay? Because I'm in my negative x-axis. Why is negative 1, not positive 1? Because I'm in my negative x-axis. Yeah. Okay? So that is your answer. And you can get different variations depending on what angles you use. I use 45 and minus 120, right? You can have various, not various, but different solutions, different looking solutions, but the eventual value of it would be the same. So a variation would be negative square root of 6 minus square root of 2 over 4.
But like crazy cosine.
Oh, I don't know yet. Probably not. Okay. All right. Okay. Try and work through this one. This is a verifying or proving one. Okay. Oh, I pronounced. Try that one. So for this one here, right, we're gonna start off with the right hand side because it looks more complicated than the left hand side. This one has is special because you can use the left hand side to get the right hand side. But I chose the right hand side to get to the left hand side. So since this is the difference formula for sine, remember sine can't change signs, right? So x, y, minus, minus, all over cosine of x times cosine of y. Okay, I just expanded out that numerator. Now this, my denominator, goes into both this and this. Okay? It's split up into both. So I put a minus sign in between. So I have sine of x cosine of y over cosine x times cosine y minus cosine x sine of y over cosine x times cosine of y. Right? I just split the two up. I split my denominator up. So in my first fraction, I can get rid of cosine of y. In my second fraction, I can get rid of cosine of x. Right? Because cosine of y times cosine, or divided by cosine of y is just 1. So I have sine of x over cosine of x minus sine of y over cosine of y. Sine over cosine is tangent. Which is the same thing that I have up here. Okay? Okay? So I started off with my right-hand side. I did all of this, and I got this, right? Yeah?
Can you show it a little bit?
If I started off with this, to make it look like the right-hand side, I would turn both tangent of x and tangent of y into sine and cosine. So sine of x over cosine of x minus sine of y over cosine of y. Now I'm going to turn this into my right-hand side, okay? So here, since I have two fractions, I can come up with my common denominator, which would be cosine of x times cosine of y, right? So in this case, in my left fraction here, I need to multiply this by cosine of y over cosine of y, right? Cosine of x times cosine of y is cosine x cosine y. So in this guy here, I have sine of x times cosine of y, right? Doing the same thing here, I have cosine of y here. I need it to be cosine of x times cosine of y. So I need to multiply this by cosine of x, okay? Minus, 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 cosine of x times sine of y over this denominator. So S, C, C, S, that is sine can't change signs. So that my numerator would be sine of the 2 degrees or 2 angle measures, just subtracted because sine can't change signs, over cosine of x times cosine. Yeah. Yeah. Okay. Questions on this? No?